Okay, we're looking at the Unit 3 review problems, and we're focusing right now on Concept 7, and this is slide number 15. We're trying to find the vertex of the function. To find the vertex, we're going to get this equation in graphing form. So I'm just going to replace the f of x with a y. Getting it in graphing form requires us to move the c value over to the other side. Here my a value is 1, so I don't have to factor out my a value. I can go ahead and complete the square as my next step. So b divided by 2 is 1, 1 squared is 1. I can add a 1 over here as well, so that's y plus 25 equals x plus 1 squared. So our vertex of this function is at -1, -25. Okay, now looking at problem number 17, determine the coordinates of all points of intersection. We can do this graphing both of these and then finding the points where they intersect, or do it algebraically. So since we don't have a grid here, I'm just going to go ahead and show this algebraically. We can substitute using the equal values method x minus 2 in place of the y. By doing that, we get x minus 2 equals x minus 3 squared minus 1. And I'm going to go ahead and multiply x minus 3 times x minus 3 out, which gives us x squared minus 6x plus 9. So combining like terms, I'm going to move these over to this side. X squared minus 7x, this is 8 plus 2 is 10. Factoring this would give us x minus 5 times x minus 2. So my x values of intersection are at +5 and +2. Now we need to find the corresponding y values. So y is equal to x minus 2. So here y would be equal to 5 minus 2, which is 3. Here y would be equal to 2 minus 2, which is 0. So my points of intersection are at 5, 3, and at 2, 0. All right, looking at number 18. Number 18, concept 7 is asking us to find the y-intercept as opposed to the x-intercept. To find x-intercepts, we set the y equal to 0. To find the y-intercept, we need to set x equal to 0. So by substituting 0 for x, that gives us 2 times -4 squared is 16. Y is equal to 32 plus 2, or 34. So my y-intercept is at 0, 34.